Week 5 focuses on function rules and comparing functions. Number 1 says which point on the graph of the function y equals 3 times x plus 2. So if I substitute in for x and y into that equation where 3 is the slope and 2 is the y-intercept for the x and the y that are given, for point A, when I substitute the 5 and the 1 in, 3 times 1 is 3, plus 2 equals 5. 5 is equal to 5, so that one is a solution. But let's double check. On number B, question B, point B, 3 times 2 is 6. 6 plus 2 is 8. 3 is not equal to 8, so that is not a solution to that function, or is not on the graph of that function. C, the point 3, 2. 3 times 3 is 9, plus 2 is 11. 11 is not equal to 2, so that is not on the function. And last, we have the point 5, 1. 3 times 5 is 15, plus 2 is 17. 17 is not equal to 1. So the only point that is on this function, y equals 3x plus 2, is the ordered pair 1, 5. Question 2 says this table shows a linear relationship between the age of a newborn baby in weeks and their weight. Well, if we find the weight of the baby when it was first born, that will help us find our y-intercept. And if we look at the change in y over the change in x, and we have 2 over 2, we have 7 over 7, and we have 2 over 2 again, and those are all a slope of 1. So 1 pound per week is the rate of change, or the slope, for this function. So if we decrease the number of weeks by 1, then we decrease the number of pounds by 1, then the baby at birth was 5 pounds. So at birth, the baby is 5 pounds. Or the initial weight, which then would be my y-intercept. So the equation says select all true statements. The weight of the baby increases at a constant rate of 2 pounds every week. Well, if we look at our rate, we said it was going to be 1 pound per week. So it's not 2 pounds every week. So that is not a true statement. B says the weight of the baby increases at a constant rate of 1 pound every week. That matches what we found. So B is a true statement. But it says select all the true statements, so we have to keep going. The weight of the baby increases at a constant rate of half a pound every week. That does not fit what we found, so we know that is not a true statement. Now we have to determine whether age is a function of weight or if weight is a function of age. Well, what depends? The dependent is the function of the independent. Well, what is my dependent? What depends on the other? Does age depend on the weight, or does the weight of the function depend on the age? Well, in this case, weight is your dependent and age is your independent. Age is not a function of weight, but weight is a function of age. So E is correct. Let me clarify, in some situations, it could be possible for age to be a function of weight. So this may be a true statement as well. The next question says the graph shows the amount of water in a bathtub starting at 10 a.m., p.m., doesn't matter. Select all true statements. So if this is 10 and we're going by 2 minutes, so 10:02, 10:04, 10:06, 10:08, 10:10, 10:12, 10:14, 10:16, 10:18, 10:20. Oh, it is p.m. It does say that. Sorry. And I look at my graph. From 10 to 10:02, it's increasing. And that's the amount of water in the tub, so it's increasing very quickly. So it seems the tub is filling up to 30 gallons. Then there is a constant where the amount in the tub stays the same until from 10:02 to 10:12. And then maybe the water gets cold and they add 5 more gallons of water between 10:12 and 10:16. And then at 10:16, they decide to let the water out. And there's a steep decrease in the amount of water in the tank until 10:20, when there is no longer any water in the tub. Now, which of these statements are true about this graph? The tub was filling faster at 10:14 than at 10:01. 10:14, it's in this increase area. At 10:01, it's in this increase area. The steeper line is going to be faster, filling faster. It says 10:14 was faster than 10:01. 10:01 is steeper, so this is backwards and it's false. So that is not a true statement. At 10:06, we're at a constant. The tub was neither filling nor draining. Well, if it's at constant, it's not filling and it's not draining, so that is a true statement. C, the maximum amount of water in the tub was about 35 gallons. Well, if we look at this point, where is the maximum amount in the tub? It's the highest point. It's halfway between 30 and 40, which would be 35. So, yes, the maximum amount was 35 gallons. So this is also a true statement. D, the amount of water in the tub stayed the same from 10:16 to 10:20. Well, from 10:16 to 10:20, it dropped, so it did not stay the same. So that is not a true statement. And E says it took 4 minutes for the tub to drain. Well, it was draining from 10:16 to 10:20. From 10:16 to 10:20 is 4 minutes. So it did take 4 minutes to drain. So that is a true statement. So B, C, and E are all true statements for this graph. Question 4, Mai hiked up a trail for 40 minutes. The graph shows the elevation in feet that she reached throughout her hike. Name the time period where Mai gained elevation at the fastest rate. Well, I'm looking at each section where I found a bend or a change in speed of how fast or what the elevation, how the elevation was increasing. From 0 to 10 minutes, it stayed in a straight line. From 10 to 22 minutes, it stayed in another straight line. Then it increased from 22 to 26 minutes. It somewhat decreased from 26 to 32 minutes. And then it started to flatten out some again from 32 to 40 minutes, where they reached the highest elevation. So the period that had the fastest rate would be the one with the steepest line. Steepest line is from here to here. which would be from 22 to 26 minutes into the hike. And from about 95 to 160 feet in elevation. Number 5, a tree planted today has a height of 5 feet, so it's starting at 5 feet, and plus it grows 1 foot each month. Each month tells me this is my slope or my rate of change, my unit rate. Is the height of the tree a function of the number of months? So the total height is equal to 1 foot per month plus the 5 feet it started with. So is the height a function of months? Yes, it is. If so, is it linear or nonlinear function? Explain your reasoning. This is a linear equation. So it must be linear. Why? Because it's a constant rate of change, or a constant increase each month. Question 6 has 3 parts referring to 2 cleaning services. 2 cleaning services charge money for each hour of work plus a one-time fee. So a one-time fee would be my initial fee or my startup fee, or in my equation, it's my y-intercept. The charge for each hour of work is my unit rate or my slope. We have Sparkle Teen Cleaners and we have So Fresh and So Clean. And their charges, one in a graph and one in a table. If we look at the table, we're going to look at the rate of change. Change in y over change in x. Change in y over change in x would be 8 over 1, and 16 over 2, and yes, is a constant rate of change, is $8 per hour. If we take that 1 hour away, and we take 1 hour of charge away, so minus 8, then we find out with 0 hours work just for them to come to the house that they charge $20 fee. For So Fresh and So Clean, we can look at our graph and see that they charge an initial fee of $15 for their one-time fee. Then we need to see, what are they charging per hour? Well, here is 1 hour. From 15, it increases to 25 during that 1 hour. So that's an increase of $10 per hour. So the rate of change, or rate of cost per hour, is $10 per hour for So Fresh and So Clean. Question A says, a customer would like a company to visit their home and give a quote without doing further work. Which company is the most cost-effective? Most cost-effective means the cheapest that will come just to give an estimate. Well, who charges the least amount for the one-time fee? That's going to be your cheapest or your most cost-effective for this person. Sparkle charges $20 for the one-time fee. So Fresh and So Clean charges $15 for the one-time fee. So therefore, So Fresh and So Clean would be the best choice. And it says, explain your answer. So Fresh and So Clean charges less of a one-time fee. So would be the better choice. Question B asks, another customer would like the company to perform 7 hours of work. Which company should this customer choose? Well, if we look at what we know, cost is equal to $8 per hour plus the $20 fee for Sparkle. And the cost is equal to $10 per hour plus the $15 fee for So Fresh, So Clean. So if we substitute $7 into each of these equations, we can find out who charges less. 8 times 7 is 56, plus the 20 would be a total charge of $76 for Sparkle. 10 times 7 is 70, plus $15 one-time fee is $85 for So Fresh, So Clean. So the better choice would be Sparkle. Why? Because it would cost less for them to do the 7 hours work. The last question says, what is the smallest number of hours of work for which Sparkle Team Cleaners is the cheapest? So if I find out where they become equal to each other, I know at 7 hours, Sparkle is still cheaper. So let's find out between the two, which one, where they become equal. So we set the equations of each equal to each other, and then we solve. If I subtract 8 hours from both sides, 20 will be equal to 2h plus 15. We subtract 15 from both sides. Then 5 will equal $2h. If I divide by 2 on each side, then my h is 2.5 hours. That's where they become equal. Therefore, the least number of hours that Sparkle could work and still be less than or equal to, they would be equal at 2.5 hours, so the least number of hours they could work and still be cheaper would be 3 hours. This would be equal. They would cost the same at 2.5 hours. Sparkle would be less at 3 hours. And that is week 5.